In this video, I'll work through several practice problems using the chain rule and its combination with other rules that we've learned. So this was problem number 2 on the worksheet that we had today. And so what we need to realize when we look at this function is that ultimately this is a product. So the last operation that happens in constructing this function is that we take e to the x squared plus 1 and multiply it by the sine of x cubed. Since product was the last operation, that means that the product rule is the rule that we need to use first. So we'll call the first function f and the second function g. So that means that my y prime is going to be f prime times g plus f times g prime. So for f prime, I need to look at e to the x squared plus 1 and think of that as e to the u. The derivative of e to the u is e to the u. So the derivative of e to the x squared plus 1 is e to the x squared plus 1. But then by the chain rule, I have to multiply by u prime. The derivative of x squared plus 1 is 2x. Now for g, I just copy and paste. Sine of x cubed. For f, again, I just copy and paste, so I get e to the x squared plus 1. And then finally for g prime, I need to look at sine of x cubed and think of that as the sine of u. And the derivative of the sine of u is cosine of u, so that's cosine of x cubed. And then we multiply that by u prime, the derivative of x cubed is 3x squared. For the next one, we look at this function and notice that dividing is the last operation. We've got this function on the top, e to the 4x, divided by this function on the bottom, 2x minus 7 to the 5th. So we call the top function f, we call the bottom function g, and we use our quotient rule. And the quotient rule tells us that our derivative is f prime times g minus f times g prime divided by g squared. So for our f prime, we look at e to the 4x and think of that as e to the u. The derivative of e to the u is e to the u, because the derivative of e to the x is e to the x. So the derivative of e to the 4x is e to the 4x, but then we have to multiply by the derivative of 4x, which is 4. There we're using the chain rule. Now we multiply by g, which is just 2x minus 7 to the 5th power, minus f, which is e to the 4x. And then finally g prime, we look at 2x minus 7 to the 5th and think of that as u to the 5th. The derivative of u to the 5th is 5u to the 4th. So we get 5 times 2x minus 7 to the 4th, multiplied by the derivative of that u, and the derivative of 2x minus 7 is 2. Divide that by 2x minus 7 to the 5th squared, and we're done. Now we've got cosine to the 4th of 7x cubed, and my advice here is, because of this exponential notation being a little bit confusing, let's just rewrite this function. We're not taking any derivatives yet. We're just going to rewrite it in a more easy to understand notation, which is as 7x cubed all raised to the 4th power. When we do that, that makes it easier to recognize that the last operation here is raising to the 4th power. So my derivative of u to the 4th is 4u to the 3rd. So 4 times cosine 7x cubed to the 3rd power. But then we have to multiply by the derivative of cosine of 7x cubed. So what goes in this spot here is the derivative of that u, the derivative of the cosine of 7x cubed. Well, we think of the cosine of 7x cubed as the cosine of u, or we could call it v if we don't want to get confused with the u that we already used. But the derivative of the cosine of u is minus the sine of u. But then we have to multiply that by the derivative of u, which is 21x squared. 7 times 3 is 21. And that's our derivative. Next up, we've got the derivative of the square root of 1 plus the square root of x. So the outermost operation, the last thing that happens is that big square root. Now to help us easier take this derivative, let's rewrite that as raised to the 1/2 power. That's going to make it a little easier so we can use our power rule. So the derivative of u to the 1/2, that's how we're going to think about this, is u to the 1/2. The derivative of u to the 1/2 is 1/2 times u to the minus 1/2. But then we have to multiply by the derivative of that u. So what's going to go in this spot here is the derivative of the u, which was 1 plus the square root of x. And again, we'll rewrite that using a fractional exponent, 1 plus x to the 1/2. So the derivative of 1 is 0, and the derivative of x to the 1/2 is 1/2 x to the minus 1/2. Now for the next couple of examples, we're looking at finding y double prime. But the first thing we need to do before we can find y double prime is find y prime. So if y equals the cosine of x squared here, we're going to think of that as the cosine of u. And so the derivative of the cosine of u is negative sine of u multiplied by u prime, which is 2x. So that's my y prime, not too bad, a simple application of the chain rule. But now I have to find y double prime. And so when I look at y prime here, what I should notice is that it is a product. If I think of this first function as f and this second function as g, then I need to use the product rule. So I've got f prime. Now the derivative of negative sine of x squared, we're going to think of that as negative sine of u. That negative is a constant multiple, so that's just going to stick around. The derivative of sine of u is cosine of u, but then we have to multiply by the derivative of u. So that's my f prime. All of this right here is f prime, times g, which is 2x, plus f, which is minus the sine of x squared, multiplied by g prime, which is just 2. And that's our y double prime. Now we've got a cube root problem, so just like with square root we write with a 1/2 exponent, we're going to rewrite this with a 1/3 exponent. So we'll write this as 5x cubed plus 1, all raised to the 1/3 power. And again, the power rule does work for these fractional exponents, as we'll learn soon. So y prime, if we think of this as u to the 1/3, the derivative is going to be 1/3, and then we take that exponent and subtract 1. And when we subtract 1 from 1/3, what we end up with is negative 2/3. But then we have to multiply by the derivative of that inside function, multiply by the derivative of u, which is going to be 15x squared. Now, if we see any easy simplifications here, we should probably do them, because the simpler our first derivative is going to look, the easier our second derivative is going to be to figure out. And so I can simplify here a little bit. This 1/3 and this 15 is going to give me a 5. And if I rewrite this in sort of the normal form, what we end up with is 5x squared times 5x cubed plus 1 to the minus 2/3. And now let's look for y double prime. What we should recognize here is that this y prime is a product. If I call this first function f and this whole big second function g, then this is going to be a product rule problem. So it's f prime, which is just going to be 10x, multiplied by g, which is just copying and pasting here, 5x cubed plus 1 to the negative 2/3, plus f, which is 5x squared, multiplied by g prime. Now g here, I'm going to think of as u to the negative 2/3. And again, I can use my power rule for those weird fractional exponents. So how does my power rule work? Well, I bring my power down, negative 2/3, times u, 5x cubed plus 1, and now I'm going to subtract 1 from that exponent. When I take negative 2/3 and subtract 1, what I end up with is negative 5/3. But then I also have to multiply by the derivative of u using the chain rule, which means I need to multiply by 15x squared. So all of this here, that was my g prime. So this was f prime, this was g, this was f, and that was g prime, using my product rule. All right, and the last one for this video. So we look at our y here, and again, what we want to recognize is that dividing is the final operation. So that means the top function I'm going to call f, the bottom function I'm going to call g, and so my y prime is going to be my quotient rule. So it's the derivative of the top times the bottom minus the top times the derivative of the bottom, all divided by the bottom squared. Now we want to try to make this as simple as we can to make taking the second derivative easier. I don't recommend multiplying out the bottom because that being factored is actually going to make the derivative relatively simple. But let's try to see if we can try to collect some like terms and simplify the top here. So on the top what we have is x squared plus 4, and then minus x times 2x gives us minus 2x squared. And so we end up with negative x squared plus 4 all over x squared plus 4 squared. So that's as simple as we're going to get that, but now we can take y double prime a little bit more easily. Again, we have a quotient, so our top function is f, our bottom function is g. So our quotient rule tells us that we have the derivative of the top, which is negative 2x, times the bottom, which is x squared plus 4 squared, minus the top, negative x squared plus 4, multiplied by the derivative of the bottom. Now the derivative of the bottom is going to require the chain rule. X squared plus 4 squared, think of that as u squared. So that'll be 2 times x squared plus 4 to the first power, multiplied by the derivative of x squared plus 4, which is 2x. So that's my g prime. And then finally I divide by g squared, so that'll be x squared plus 4 squared squared. Now, it made sense to simplify our y prime to make getting y double prime more easier, but y double prime is what we were looking for, and even though it's not simplified, we can just leave it like this because y prime was our goal and we got there. So that's it for these practice problems. Hopefully this video helped. If you've got any more questions about this stuff, please come see me in office hours or shoot me an email or ask me a question either before class or after class. I'd be happy to work with you on these. They can be long, they can be complicated, but you'll definitely see problems like this on our next exam.